AWS RDS MySQL service and architecture. When we started this module, we looked at the relational database architecture. Then we looked at the characteristics of a managed database. What would a cloud database provider offer for us? In this section, we are going to look at the AWS RDS, which is the relational data service for MySQL database, and look at its architecture. So what are the objectives of this section? We'll define what RDS is. We will look at its features. Then we'll look at some of the usage patterns of an RDS. We'll look at the architecture. This is where we're going to be spending most of our time. Then we will see what it takes to launch a database instance. And then we'll see what do we need to do to connect to a database instance. So what is RDS? RDS stands for Relational Database Service. It is an AWS cloud service. This is the official symbol for RDS. It's a service that makes it easy to set up a database, operate a database, and most importantly, scale a relational database instance in the cloud. We don't really have to get any servers. We don't have to install any operating systems. We don't have to install any database. It's managed and ready to go for us. They claim that they provide cost-efficient and resizable capacity. That's what AWS claims. It's quite true. They manage the time-consuming database administration tasks like backups and snapshots and failover. They allow users to focus on applications rather than the management, which is really the goal of a cloud database service. So what are the features? It is simple to deploy database service. In other words, all you have to do is use the management console or even a simple API call to launch a production-ready database in minutes. You don't have to worry about any of the infrastructure provisioning at all. They automatically launch an instance, install the database, and ready to go. It's managed, of course, handles all the time-consuming database management tasks such as backups and patch management and replication. After you finish this section, you would wonder what a DBA has to do anymore. Compatible. Once you instantiate a cloud database, then you'll notice that you can use any of the native client tools such as MySQL Workbench for MySQL or any kind of client application. As long as it talks natively to that particular database, you can use them to connect to the database. And so all the existing tools should be compatible with the existing applications, which they are. Pre-configured parameters. When a database instance is launched, it may be a small, medium, large instance. They configure the database with certain properties. Every database has some configuration. They pre-configure it with the appropriate set of parameters for that particular DB instance class. Now, as an administrator, you may want to have additional control, which they allow you to do using something called DB parameter groups. In terms of monitoring and metrics, we know that there is a service called CloudWatch, so it integrates very well with CloudWatch for monitoring and metrics. Automatic software patching. A database is a very special beast. There is typically one database server that's running, that's taking all the write requests, also the read requests, but you can have read replicas. And so you cannot really bring it down and update it. It has to be done in a very specialized manner. And especially small patch updates, you don't want to be going around and managing that yourselves. The cloud vendor, in this particular case, AWS vendor, automatically does that. Automated backups. Automated backups are turned on by default. When you launch an instance, a backup is set for at least 1 day. You can change it to 7 days or 20 days or 35 days. I think there's a maximum for it. 35 days is the maximum. And this allows you to enable a point-in-time recovery for the DB instance. You can recover the database to any instance in time within the backup period. There are also this concept called DB snapshots that are user-initiated backups versus automated backups. These are user-initiated, which will be stored until explicitly deleted. And you can use these snapshots to create new instances. There are also DB event notifications. There is the SNS service, which is the simple notification service. DB events are integrated with SNS so that notifications can be sent via mail or SMS for the various events, such as the database has been created, the database is being upgraded, the database is being rebooted. All those events can be sent to an email or to a phone number for texting. Multi-availability zone deployments. You can have a primary master database in one availability zone with slave running in another availability zone for failover. So in case the master dies in one data center, that is the first availability zone, the database will be automatically launched in the second availability zone or the failover availability zone. So you have the least amount of interruption for your database service. There are also various storage options that are supported. You have magnetic, general purpose, and provision IOPS, each having its own special profile, small, medium, large performance. Push button scaling, if you want to scale vertically or horizontally, you can do that through the console. You scale vertically by getting larger machines, and you scale horizontally by creating read replicas. There is also automatic host replacement, which is when there is a hardware failure, the RDS service will automatically replace the compute instance by powering a new instance. There's also replication, provides two distinct but complementary replication features. You have what is called the multi-AZ deployments that allow you to have availability, and then you also have read replicas that allow you to get scalability for your application. There is isolation and security. You can isolate the database instances in your own network using VPC. It is also possible to encrypt your database data, the actual data itself, using keys. There's also resource level permission controls that you have. You have the ability to control the access to the instance, snapshot, and replica. We looked at several features at a high level. We'll be looking at these features in great detail throughout this section and the next section on architectural capabilities. Let's look at some of the usage patterns. You can launch databases on the fly in an automated fashion. Imagine how much time it takes within an enterprise environment for you to launch a database. Here, it's very easy. With a click of a button on the console or by running a command, you can instantiate a database instance. You can launch or instantiate a database instance, which is a simple database instance for dev and unit testing. Or you can launch a complex, high available database instance for performance testing and production environments. You can also clone databases for reporting. RDS architectural components. There are several components, terms that are part of the RDS architecture that we should make ourselves familiarized with so that it makes it easy for us when we start using the RDS service. They are DB instance, DB engine, DB engine version, the license model, database storage, DB parameter groups and DB option groups, multi-AZ, read replicas, backup, restore, and promotion. Let's look at these concepts in more detail. DB instance. A DB instance is an isolated database environment in the cloud. This is the instance with which the applications are going to be interacting with. This is the actual database. Each database instance runs a database engine. We'll talk more about the engine in the next slide. A database instance can contain multiple user-created schema. So you may have a database instance called my server, and inside it there may be several schemas. Schema for database 1, my DB1, my DB2, or the name of the database, the name of the project. And you can access the database instance through traditional tools. For example, if you're going to be working with MySQL database, then you can use MySQL Workbench or any kind of MySQL client, a Java application with a MySQL driver, or any other tool that you traditionally use. You cannot have direct access to the instance. If you recall, in Elastic Beanstalk, they would actually launch an instance for you, and then you could actually log into the instance where Tomcat or Apache was running. For RDS, you have an instance, but you do not have access to the instance. In other words, you don't directly log into the instance. You're not allowed to do that. DB instance name identifier. Every database instance has a database instance identifier. It's a unique name that identifies that particular instance. This is an AWS user or customer supplied name, so you have to supply this particular name. And this name is used in the DNS name for the database endpoint. If you recall, we talked about endpoints. Endpoint is the host name and port combination. The DB identifier is what is used for the endpoint host name. So it is used when you're interacting with the RDS API. A DB engine. There are multiple database engines that are supported by RDS. They are MySQL, Oracle, Microsoft SQL, Postgres. Now, of course, these are your standard databases that's available in the marketplace. There is also something called Aurora, which is a new proprietary engine that AWS RDS guys have introduced that is an engine that emulates MySQL. So it's very easy. This is their own compatible implementation of MySQL. I personally have not played much with Aurora. From what I understand, it's very similar to MySQL, so you can easily port from MySQL to Aurora. They claim that it's faster than MySQL. Now let's look at the DB engine version. Multiple versions of the same engine may be supported by AWS RDS, which means when you have MySQL, there are multiple versions of MySQL that are supported by the AWS RDS service. They also have a concept of major and minor versions, and it's determined differently for the various database engines. Since we are going to be working with MySQL, let's understand the MySQL version number, and let's understand the concept of MySQL major and minor version numbers. In MySQL, version numbers are organized as x.y.z. X being the major version number, Y being the release level, and Z being the version number within release series. And so when it comes to the major change, as long as the X and Y change, it is considered to be a major change in release. For example, if you go from 5.1 to 5.5, that's considered to be a major change in release. A minor change in release is when the Z changes. So for example, if you go from 5.1.45 to 5.1.49, that's a minor change. Now, why is understanding the version numbers important? That's because when you instantiate an RDS instance, you can actually turn a feature that says you would like automated updates. And if it's a minor change in release, then they can automatically do the update for you, provided that you choose that option. The license model. RDS supports several license models. There is the general public license, which is usually applied for open source software, such as the MySQL database, where there's really no license fee that you have. There is also bring your own license, which is also called BYOL. For example, it applies to Oracle and Microsoft SQL Server. You as an enterprise may have negotiated a deal with Oracle or Microsoft for the database licenses. If you want, you can instantiate a database instance. Let's say you instantiate an Oracle instance, and rather than buying the license from AWS, you can actually bring in your own license, which is what they call bring your own license model. Or you can get an instance where the license price is already included. And that would be the third model, which is the license included. So it can apply to Oracle and Microsoft SQL Server. Database storage. There are three different storage options, and you have the option to select one of the three. There is the magnetic storage. It is suitable for small databases where the data is accessed less frequently, great for dev environments. There is also general purpose SSD, which is suitable for a broad range of database workloads. It works fairly well across many different kinds of applications. But if you're looking for a database that has very high IO intensive needs, then you can go with provisioned IOPS SSD. Database settings. Each instance comes with the default settings for the database. Every database actually has settings, and these settings are already pre-configured by AWS. The AWS has already set all the best possible setting, taking into consideration the DB instance size, DB engine, DB version, and the storage type. But you may still want to tweak the settings of the database. And you can do that using two different techniques. One is the DB parameter groups and the other one is DB option groups. Let's look at them. DB parameter groups. It is used to manage the configuration of a database engine. For example, in MySQL, in my.conf file, which is my.cnf file, you have settings for bin log cache size, flush time, and there are hundreds of settings. You may want to tune it for your database instance. You can do that using parameter groups. And the idea here is that because RDS has default parameter groups that are there, what you can do is you can take one of the default parameter groups, save it, and then create a new parameter group with new set of values and apply that to many instances. You don't have to just apply to one instance, but you can apply to maybe multiple instances at the same time. That's the idea behind DB parameter groups. So take existing default parameters, create a new DB parameter group, change the values to the value that you want, and apply it to the database. There is also DB option groups. This is another way to set parameters, and in this case it's more about additional features of a database. When you get MySQL, you get the base MySQL, but MySQL also can work in conjunction with memcached. So you can bring in the memcached option using the DB option group. For example, in Oracle, if you bring in Oracle instance, you get the base Oracle instance, but what if you want XMLDB or Apex? That's also available, and you bring in those options using the DB option groups. So you can think of DB parameters and DB options as mechanism by which you can kind of configure and set your database. Once again, RDS applies default option group if you've not already supplied it, and it's possible to create a new option group with new values and apply to many instances of the database. You also have multi-AZ deployment, which is multi-availability zone deployment. RDS optionally provisions maintains a standby replica in a different availability zone provided that you choose the multi-AZ option. When you choose the multi-AZ option, you will have a master database running in one availability zone, and you will also have another slave database running in another availability zone. In situations where the master fails, the slave or the standby will be made into the new master. This is all done using proprietary synchronous replication between the masters and the slaves, and this helps you in availability. We'll talk more about this in the architectural capabilities for availability. Read replica. Read replica is the process of creating a slave database from a master, more of a read-only database from a master. You can have multiple read replicas created from the master. Once a read replica is created, any updates that are done into the master, any new data that's committed into the master will be automatically replicated to both the slaves. All the slaves will end up getting the changes. It uses built-in asynchronous MySQL replication for read replicas. Please understand that the replication scheme between the master and the read replica is an asynchronous replication, async replication, whereas the replication between the master and the standby or slave database is actually synchronous replication. That would be synchronous replication, which is a proprietary replication. Read replicas can be created within the same availability zone or another availability zone, whereas the slaves or the standby machines are created in the other availability zone for multi-AZ deployments. Read replicas have its own connect strings. These guys have their own connect strings, which means the applications can connect to a read replica for read-only queries and connect to the master for write queries. That's how you get scalability. We'll talk more about this in the section on performance and scalability. There is also backup. Databases require backups, and RDS provides two different methods for backing up and restoring your database. There's automated backup and snapshots. Let's look at automated backup. When you create an instance, you have the opportunity to say that you want automated backup. In fact, by default, the automated backup is turned on unless you explicitly turn it off. You explicitly turn it off by setting the backup period to 0. If you turn the automated backup on, then it will automatically create a backup of the database daily. It also starts capturing transaction logs. So let's say that it starts creating the automated snapshots or automated backups daily at 3 a.m. in the morning. It will also have all the transaction logs starting from 3 a.m. in the morning so that you can actually recover any point in time. The automated backup concept works for InnoDB storage only. Backup happens during provided window. You can specify the window when the backup needs to take place. Backups are kept for a configurable number of days. You can configure the backup for 7 days or 8 days or 21 days. I think the maximum it goes to is 35 days at this point. And by the way, automated backup is required for read replica creation. If you don't have automated backup, then you cannot create a read replica. DB snapshot. A DB snapshot is a user-initiated backup of a database instance. It's like a backup, except it's the user that's initiating the backup, so you can even call it a manual backup. It backs up the database at the specific instance in time. You can run the DB snapshot anytime you want. This can be done for InnoDB database or the MyISM engines. It's used to restore the database to that instance in time. Whenever you took the backup, whatever the instance time it was, that would be the time to which you can restore. That's how the DB snapshots work. DB snapshots are kept until explicitly deleted. The automated backups automatically get deleted. So if you say you want a backup for 21 days, every day a backup will be taken for 21 days. When the 22nd day comes about, then the old, which is the 21st backup, will be automatically deleted. One of the ways by which you can use a DB snapshot is by taking a DB snapshot before any kind of an application upgrade. That's something that you may want to do. Restore. RDS provides two different restore options. You can restore to point in time, or you can restore from a snapshot. In both situations, whenever you restore, it creates a brand new instance. So let's look at restoring the database to point in time. This works only with automated backup. When you have automated backup in time, you can restore the database to a point in time. You can say, I want to restore the database to this date, to this time, and it will do that. But as long as the data is within the backup period. The way it works is that it uses the automated backup and change logs to recreate database to a specific instance in time. If you recall, I said to you, there are change logs that are being maintained. It uses that in combination with the latest backup for that time period in order to recreate the database to a point in time. Point in time must be within the automated backup window. Latest restorable time for a database instance is typically within 5 minutes of the current time. So let's say if your database crashes hard and you want to restore the database, you can at most restore it to within the 5 minutes of the crash time. Restore from snapshot. It works with both automated and manual snapshot. You can take the automated snapshot or the manual snapshot, and you can restore a database from that snapshot. Don't forget, when you restore a database, a new instance will be created. So uses the snapshot to build the database. It retrieves the database to the instance it was backed up. So whenever the backup was created, whether it was manual or automated, it would actually bring it to that point in time. So it's not really a specific point in time, it's whatever the backup time was for that particular snapshot. Promotion. There is also a concept of promotion where if there are multiple read replicas, multiple slaves, you can promote one of the slaves to be a master. The process of taking a read replica and making it into a master is what we call a promotion. During promotion, one has the option of opting out of the automated backup. Before promoting a slave to be a master, it's better to stop transactions in the master for the slave to catch up and wait for read replica lag to be 0. What I'm trying to say here is that if you have a master and then you have a slave read replica, before you convert this slave into a new master, what you want to do is, remember, when you have a master-slave relationship, there is replication that's going on, and it's asynchronous replication. It takes a few seconds for the records to be replicated from the master to the slave. If you want all the records from the master to the slave appear before you convert this slave into a master, you want to make sure that all the transactions have been committed and stopped before you actually take the slave and make it into a master, or make the read replica into a master. Promotion is irreversible, which means you cannot restart the replication. Once you promote the read replica into a master, then it has no relationship with the original master. It stands on its own. Creating a database instance. How do you create a database instance? Well, you can create a database instance using the Management Console, RDS API, or command line tool, very similar to the other services. What do you need to specify to create an instance? You need to specify the database engine information. For example, what is the database engine you want, whether you want MySQL or Oracle or SQL Server. You also want to specify the database engine version, the license model that you want. In some cases, you may not have much of a choice. For example, in MySQL, it's always going to be the open source license model. And also the DB instance type. You want tiny, small, large, extra large. You also need to specify the storage info, which is what type of storage you want, magnetic or provisioned IOPS or general purpose, and also the amount of storage you want. You also need to say whether you want multi-AZ or single availability zone deployment for availability. You also want to give database settings like the database instance identifier, which is the identifier that is used in the host name to identify the instance, the master username and the master password. The master username can be typically root or admin. That's the name that many people choose, root or admin, but you can choose whatever name you want. Networking and security, you can decide to go with VPC if you want. You can also decide to go with a specific availability zone. In terms of database options, you can give the database a name, which is the default schema. This is the default schema. Remember, your database server can have many schemas, and this is going to be the default schema name. If you don't give a default schema name, which is optional, then it won't create a database. In that case, you'll have to log into the database and create your own first database schema. Port by default, if it's MySQL, it'll be 3306. DB parameter group, there is already a DB parameter group that is automatically specified. Also, DB option group, there is a default for that. In terms of automated backup, you are by default enabled a 1-day backup, but then if you want, you can turn the backup off. If you choose the backup, then you need to say what the backup time period should be, when the backup should take place. And when it comes to maintenance, auto minor versions of the updates can be turned on to yes, so that it'll automatically make updates to the database. And if you have both automated backup and maintenance update turned on, then you need to make sure that your maintenance time period does not clash with the automated time period, because they both really cannot work at the same time. In terms of accessing the database instance, once the database instance is available, then you have an endpoint, and you can use the endpoint to connect to the database. You can retrieve the endpoint through the API or the console. That will be your host point, and the port will be usually 3306 for MySQL, unless you decide to go with a different port. Using the endpoint, you can construct a connection string to connect to the database so that your Java applications or Python applications can connect to the database. You can also use your favorite database tool to access the database. For example, in MySQL, you have the MySQL Workbench. You can use that tool. You can also use your application to access the database. Like I said, you can use your Java application to connect to the database, but you'll have to use the appropriate driver. For example, you may have to use the MySQL driver to connect to the database in conjunction with using the java.sql package. In summary, RDS MySQL database is a managed MySQL database in the cloud from AWS. In terms of RDS MySQL architecture and its capabilities, there is a concept called DB instance, which is really an isolated database environment in the cloud. You create database instances in the cloud. Multiple DB engines are available for you to choose from. You can choose from MySQL, Aurora, Oracle, SQL Server. There's also a choice of different instance sizes. You can decide to go with tiny, small, large, extra large database instance size. There's also a choice of different storage types. You can go with magnetic or general purpose or provision IOPS storage type, depending upon the need of the database. Multiple versions of the same DB engines are also supported. You may decide to go with a specific engine, but there are several engines that they give you, several engine versions that they give you. There is also a concept of major and minor version numbers. If there is a change in the x.y portion of the version number, it's considered to be a major release change. If there is change only in the third number, which is the .z, then it's a minor version change. The reason that's important is because in case of minor version changes, you can have automated upgrade turned on for the small version changes. There is also a concept called DB parameter groups for tuning the database parameters. There's also a concept called DB option groups for enabling optional features like memcache. You can also have automated or manual backup. The auto backup is needed for creating read replicas. You can restore a database to a point in time with automated backup. You can have multi-AZ deployment, or which is multi-availability zone deployment for availability. You can promote a read replica to a new master if you want. In terms of creating the instance, you can use an AWS console or the RDS API for creating instances. You can also use the command line tool. It works very similar to all the other services. What's needed to create an instance? You need the information related to database engines, storage information, multi-AZ or not, networking and security, DB options, automated backup or not, and if so, how many days, maintenance window, and if so, should not overlap with the backup window.